Welcome to Algebra 2, Unit 6, Lesson 6. This is Properties of Logs Part 2. Now, if you are wondering what happened to Properties of Logs Part 1, that is a discovery activity where we will be using calculators to figure out the patterns in the decimals and try to figure out how the properties are put together. So you're going to be trying to discover these patterns on your own before doing a summary lesson where we actually look at some of the harder problems that you might be asked to do with the properties of logs. I've always thought that properties of logs are fun. I kind of view these problems as puzzles. So they're not necessarily useful by themselves, but they are useful in that they give us flexibility to rewrite logarithmic expressions in different ways. And in the next lesson, we'll come back and we'll use the properties to help us solve equations. It just is going to allow us to solve more types of equations because we'll be able to rewrite them into forms that will work with the strategies that we have. So in the previous lesson, you should have discovered the properties of logs. So in this slide, I'm just going to recap what those properties are. Now, if you're one of my students and you have not done that activity, you really should do that activity first because it's going to ground what it is that I'm about to write on the screen. So the first property governs what you do if you have two logarithms that are added together. Okay, so we have log base b of x and plus log base b of y. And what you can do that's not log base b of x plus y. So you don't actually add the x and the y together. What you do if you want to rewrite that as a single logarithm is you would multiply the x and the y. And you can actually verify this using a calculator. So if you did log of 2 plus log of 3, and then you did separately log of 6, you would notice that they are the same. Log plus 2 plus log of 3 is not the same as log of 5. It's the same as log of 6, so you can multiply that. The second property has to do with if you are subtracting two logarithms. So you might have log base b of x minus log base b of y. And if you wanted to combine those into one, you would write it as a division problem. And so that would be the log base b of x over y. And you'd always take this first, like whatever you're subtracting from, and that would be the numerator, and then whatever you're subtracting, that argument becomes the denominator. This one is easy for students to get confused with the change of base formula, which does have a log in the numerator and also in the denominator. Yeah, that can cause some issues. And then the last one is, what if you have something multiplying your logarithm? So you might have log base b of x, and you're multiplying that by some number y. Well, you can actually take that y and you can move it into the exponent. Okay, and all of these can be taught in different ways. Some years I just give them to students, like here are the properties. You can also show that these are related to the properties of exponents. So for example, if you had, say, 2 to the third times 2 to the fourth, you would add those exponents together and get 2 to the seventh. And so you see a connection there where you're multiplying, and so what you do with the exponents is you add them. Here you're multiplying, and what you do with the arguments with the logarithms is you end up adding them. And you can actually show that the properties of logs work this way by using exponents. And if you dig around online, you can find that. This year, I'm opting to present these with a discovery activity. So letting you handle the numbers and look for the patterns, and then you can see the patterns for how these properties work. So these are the three. Now, we can use these properties in either direction to rewrite logarithms in whatever way is more useful for our problem. So the two directions are often referred to as collapse and expand. So if you're going from this kind of notation over to this kind of notation, we call that collapsing, because I've heard collapsing, I've heard shrinking, you'll see different vocabulary words used to describe it. But essentially, you're taking something that's like long and then collapsing it, or condensing it is another common word, to something shorter. Okay, so if you're going from this side over this side. Now, other times you might start with something that looks like this, and you rewrite it or the way it is on the left, which would be expanding. Usually it's expanding. You might see like stretching, or I know, like choke on a piece of granola bar here. So that's awesome. So those are the two directions. By themselves, these problems are really like little puzzles. It's how can I get from where I am to where I'm supposed to be? But just like a puzzle doesn't do anything by itself. So yay, you filled in a crossword puzzle. These are kind of like that. They don't serve a purpose in and of themselves, but they do put in place tools that can be used later to solve problems. Kind of like solving a crossword puzzle isn't useful by itself, but it does help expand your vocabulary. It can introduce you to new pieces of information or trivia. It can enhance your ability to look for patterns in things. So it's not like there's no skills that are developed. So pretty much the way the lesson goes from here is I'm going to give you 3 examples of collapsing and 3 examples of expanding, and we'll stop in between those to get a little bit of practice. Now, there is some flexibility for how you do these, and if you're astute and you observe the problems, you can sometimes see shortcuts, like terms, things that would tie into other pieces of math that you can do these a little bit easier. So here I have addition. So when I am adding, I'm going to be using this property here, okay? And I'm not going to put the base on it just for the sake of time, okay? So there's a base of 3. So I see that I'm adding, which means that I'm going to end up multiplying the arguments. And I have over here an x and a y. So I know I want to multiply the x and the y. Now the problem with that is if I look at my property does not account for any potential coefficients. And my example problem here has the coefficients, got the coefficients of 2 and 4. And that means we're going to be using another property. We're going to be using this one that says that if I have a coefficient, I can write that coefficient as an exponent. And that actually needs to be where we start. So if you start a problem like this, and you're like, okay, I'm going to multiply the x and the y, and then you're asking yourself, what do I do with the 2 and the 4? Probably means that wasn't the right step to start with. So go look and see if there's another property you can apply first that's not going to lead you to that question of, I got this piece here, I don't know what to do with it. So the first thing we're going to do with this is take the coefficient of 2, and we're going to make that the exponent on the x, and we're going to take the coefficient of 4 and make that the exponent on the y. So we have log base 3 of x squared plus log base 3 of y to the 4th. Now I can go and apply that first property, except instead of x and y, I've got x squared y to the 4th, but that's just going to end up in the middle of the problem there. That's not problematic. So you'd have log base 3. And then instead of xy, you have x squared y to the 4th. It is not necessary to put the parentheses around that, but I will be doing it for clarity to show that you are taking the log of the product there, just to make sure there's no confusion. But you will see expressions without the parentheses, right? Now, these are actually all doable in one step. I think pretty much everything we're going to look at is doable in one step. That does mean that you can get away with probably copying an answer from someone. Don't. Okay, 1, wrong. And 2, not helpful to you when you have to do this on your own. So if you can legitimately do these in your head, because I can look at this and say it's going to be log base 3 of x to the 3rd, y to the 4th, all over z to the 6th. But that's because I've been doing this for a long time. Okay, and I've taught it a lot. All right. So looking at this one, we have the 3 log base 3 of x plus 4 log base 3 of y, and then we have a minus. So we're actually going to use all 3 of the properties in here. And as before, I can't combine like the adding and the subtracting piece while I still have those coefficients. So as long as you have coefficients, that's probably the first place you're going to start. I'm not going to put that down and write that as this hard and fast rule, because I have seen problems that have versions of things that are going to allow you to do different steps first. And yeah, but most of the time we would start out with log base 3, and then we're going to move the 3 into the exponent there. And then this would be log base 3, and then we'd have y to the first, and then minus log base 3 z to the 6th. And now I can do this, like I said, I can do all these in one step, but for explanation purposes, I'm going to start going left to right, because that is the direction we would do addition and subtraction. We go from left to right. So looking at log base 3 x to the third and log base 3 y to the fourth, that actually looks like the last problem we did. And so this would end up being log base 3 x to the third y to the fourth. And we're going to be working top to bottom, minus log base 3 z to the 6th. Now this is that last property here. If I have two logs that are subtracted, I can write that as a single logarithm, and we do the first argument divided by the second argument. In this problem, my first argument is x to the third, y to the fourth, and my second argument is z to the 6th. So when I go to rewrite this, I will have log base 3, x to the third, y to the fourth, over z to the 6th. Let me put some parentheses. Now, there's other ways you can do this, and that's why I don't reduce this to do this first, then this, then this. Somebody might say right here that they want to do this instead. Okay. Y to the fourth, and they're going to say plus log base 3 z to the negative 6. So in other words, instead of taking the 6 and just moving the 6 into the exponent and leaving the minus sign, they're seeing it differently. It's just that you can see it differently. So the way we did it was we just moved the 6 in and we left the minus sign there. But what if you took this and moved it as a negative 6? Negative 6 out there, then this would become a plus sign, and your negative would be floating up here. Now you have two additions, and so that would end up being log base 3 of x to the third, y to the fourth, z to the negative 6. And then we remember, oh, like a negative exponent, that means we move it into the denominator. And you'll notice we end up in the same spot. Okay, now I'm not going to advocate for the second way over the first way. I think the first way is better, but you can do it the second way. There is flexibility. You should land at the same spot. And I always like looking at different ways of doing problems, because I think we're all wired differently in what we see when we look at a problem. Some people see a minus sign, some people see it as a negative. It's the same symbol. It's the same symbol for negatives and subtraction, but how your brain processes it, there are other directions you can take. Now, where I'm going to know that you cheated is if you start the problem one way, like you have the minus sign here, and then in your next step, you suddenly have the negative in a different spot. Okay, that means you started it one way and then you got stuck and you copied it off your neighbor and you didn't notice that your neighbor was doing it a different way. So always make sure that you're engaging your brain and you're thinking about your methods and your steps, and ask questions when you get stuck. Don't just copy, ask questions. Last one. Now this one, you see there's a spot on the side there for reasoning, which means something weird is probably going to happen. Now with this one, we can actually do this a couple different ways too. Most of you though are probably going to start with that 3, and you're going to move that 3 into the exponent on the y. So your next line would be log base 2 of x minus log base 2 of y to the third, and then we'd have log base 2 of z. Okay, and in case you haven't noticed, I cross my z's. So I know that looks a little messy there on that last one. That's base 2, and then the z has a little line through it. Now I can start going left to right as I did before, okay? And we would have log base 2 of x over y to the third. So we would take that first argument and divide it by the second argument. Now I still have another subtraction. It's like, another subtraction. But math is consistent. We know math is consistent. So we know that if we're taking the first argument, dividing it by the second argument, like, okay, like moving onward. So we have x over y to the third over z. Ouch. Just what everybody wanted to see. We feel like our day goes better if we could just only have a complex fraction in it. Now, technically, that is a final answer. If what you are asked to do is to collapse a logarithm and to get it so it's a logarithm of a single argument, you have done that. It's just horrible looking. So we would like to find a better way to write it. Here's the reasoning. What we have going on over there is we have x over y to the third. Now, over the z. Now, remember that this, like a fraction bar, is division. So what we really have there is x over y to the third divided by z. So I'm going to come over here and just say that's divided by z. Now, there is no such thing as division. Your third grade teacher lied to you. They didn't really lie to you, but nobody is going to try to teach division as multiplication by the reciprocal, especially when you have not yet been taught fractions. But that is what division is. Division is simply multiplication by the reciprocal. So this would be x over y to the third times 1 over z, which means that we'd have x over y to the third z. So a nicer way of writing that would be x over y to the third z. Now, what that means for like in terms of a shortcut, because you don't want to go through this every single time. That would not be fun. Anything that's being subtracted is going to land itself in the denominator. Okay, so you got the y is being subtracted, the y is going to end up in the denominator. The z is being subtracted, the z is going to end up being the denominator. If you had something like a plus something, it would end up in the numerator. Okay, so that's kind of the short way to do it. Now, this is where that negative, using the negative exponents, you might like it better. You could do something like this as your first step, log base 2 of x plus, and then go ahead and move that negative. Okay, move that negative with the 3 into the exponent. And then remember that if you just have a minus, that's like minus 1. Okay, so you could have like z to the negative 1. What I did there, if you look up at the upper left, like it's like minus 1 log. Okay, so because there's only 1 log there, that's what you're subtracting. Now you've got it all as a like adding problem, which means that you could just multiply the arguments and then use your laws of exponents. And since both the y and the z have negative exponents, both the y and the z would shift into the denominator. So that's another way of navigating it, where that negative exponent, you might like that better, especially if you aren't sure what to do with that fraction, or you're not sure of any possible shortcut there. Okay, so those are our 3 examples. If you need to go back and rewind this video and just kind of listen through, like watch and listen through that, the explanation again, please do that. That's why I record it, so that if something goes by too fast, you have the ability to slow it down and see it again. If you're ready though, here are 2 practice problems for you to do. So pause the video. Try to work them out. Arrive at an answer. Don't just zoom through on the video. Take the time to learn. And then unpause the video, and I will share the answers with you. All right. So if you are following along at home, this first one would be log, and then it would be x squared y to the 4th z. And then remember, if you don't see a base on the log, it's a base 10 log. It's what's called a common log. And then the second one would be natural log. And then we'd have x and z to the fourth in the numerator. And then because the y was being subtracted, that's going to land itself in the denominator. So we'd have y to the third. So if you got them right, you're like, yay, got them right. If you didn't, though, that's okay, because for most of you, this is the very first time in your life that you have ever tried to do a problem like this. So make the corrections that you need to make, kind of go back and think through it again now that you have the answer, and give yourself the time to process the information. Okay, next three examples are of expanding, and this is going in the other direction. Notice I did not put the parentheses around this. So it's log base 2 of x squared times y, and this really is just reversing the process that we just did. So in this problem, I have an exponent, which is going to become a coefficient, but we don't want it to become a coefficient yet because the exponent is only on the x, it's not on the y. And so if I put the 2 down front, it's going to go with both, okay? But I do have multiplication there, and so I know that multiplication would have come from an adding problem. So I'm going to write that down and then give you a chance to think about it. We're applying the property in the other direction. Okay, so if I were to combine these, I would multiply the x squared and the y together. Now I can take the exponent on the x there and bring it down front, and it's only going to be in front of the x, not the y. And this is called expanding because we're stretching it out. Ideally, you'd want to have one logarithm for every variable that you have, or any number that was not attached to anything else. And that was vague. Sorry about that. We won't see any of those today. And nothing else messing with it. So you don't have any operations inside the logarithm. So there's no multiplication, subtraction, exponents, nothing like that going on inside the logs. Okay, next one. Okay, now here we have two different exponents. So you probably are thinking, oh, those exponents are going to go down front. They're going to be coefficients. Yes, but we have two different ones. One of them that goes with the x and one of them that goes with the y. And so we need to deal with the division first. So if you remember this property, if you are dividing, that division comes from a subtraction problem. Okay, so this is the opposite direction that we were doing before. So you would take the argument, the log of the numerator, and subtract that by the log of the denominator. So in this problem, I would have log base 4 of x to the fourth minus log base 4 of y squared. And now I can take those exponents and move them down front, and they're only going to go with the variable that they were assigned to. So this 4 would come in front of the log base 4 of x, and then the 2 comes down in front of log base 4 of y, and we have stretched it out. You guys can't see my arms, but I am stretching it out. It's dark in my classroom. All right, last one is log base 10. Now, I originally just wanted to write log, and the way I put this PowerPoint together, I was duplicating my slides so that I didn't have to keep going in, not that you guys care, but that I had to keep going into the program to type the log. And so I was like, oh, fine, we'll just keep the base 10 there. But normally, log base 10 would just be written as log, as the common log. And I have multiplication and division happening here. So you might be wondering, what order do I undo these in? Well, start with the division because like the XY is grouped together. The fraction bar is acting as a grouping symbol. So we're going to keep those grouped pretty well. And we could start off by just saying this will be log of the numerator minus the log of the denominator. And then go ahead and split this one up. So if you have two things that are multiplied, you can expand those using adding. Ta-da! And you can also think of it this way. If you think back to the other examples that we were doing, which I spent a lot more time on those first three, is stuff that's in the numerator ends up being added, stuff that's in the denominator ends up being subtracted. And so numerator is added, or it's positive here. Y was in the numerator, so we're adding it. Z was in the denominator, so we're subtracting it. I want you to be able to apply the properties to get there, but realistically, that's how I do it. I look at it and I'm like, okay, this tells me what I'm adding and what I'm subtracting. Right, as before, if you need to rewind this, I did go through these second three fairly fast. I think I did all of them in less than 5 minutes, which is a little bit fast for a video explanation, but go back and rewind and watch the examples again as needed. And here we go with our second two practice problems. So pause the video, actually pause the video and arrive at an answer. Okay, arrive at your answer and then unpause the video and I will give you the answers and then you can check it and make corrections. If you're one of my students, you're going to use that to ask questions so that you know how to do the problems yourself. Okay, so for this first one, we're going to have log base 2 of 3 plus 2 log base 2 of x minus log base 2 of y. Now, you might have kept the 3 with the x, and here's why you don't want to do that. So if you're like, oh, crud, I thought I had it. I was so confident, and you've got the 3, and your 3 is over here, okay? So if you did that, here's the piece that you missed and you need to keep in mind. And don't beat yourself up over it, okay? This is really common. That exponent of 2 only goes with the x. It doesn't go with the 3. And so if you've got the 3 still stuck to the x and the 2 is out in front, what that means is that you now have the 2 also being that exponent being attached to the 3. And so you need to split up the 3 and the x squared first and then move the 2 down front. So that's a common thing to do, or you might have thought to do this and then you weren't sure if you could do log base 2 of 3. That's just a number, and yes, you can write it out there. And yeah, so that's the first one. And the second one here is going to be 2 log base 4 of x plus 4 log base 4 of y plus 6 log base 4 of z. And if you are able to do many of these in one step, that's totally fine. Okay, so you're not going to get direct deductions from me anyway. Not to say somebody else might make a deduction if they've given you other directions for what they want to see laid out on the page, but you will not get that from me. So those are the two practice problems, and that brings us to our last slide, which is our homework. And I was getting tired at this point of opening up the typing program in PowerPoint. So homework, numbers 1 through 4, you're going to collapse them, and numbers 5 through 8, I want you to expand them. Show as much work as you need to show to be able to do it. And you'll notice we got over here on the right-hand side some interesting stuff. So we have looked at square roots recently in terms of what they mean as an exponent. We've covered that before in a previous lesson, but we've also looked at it recently. We've also looked at, we looked at in this lesson with the -4. So I'll let you guys tackle with that. As always, you know how to reach me if you have questions, and I will see you next time.